Hello, AP Statistics students. Mr. McNichols and I want to send out our video for Chapter 7, a few hints, tips, reminders, and resources. Speaking of reminders, seniors, this is the week where you drop off your textbooks and materials back to school. But if you want to keep your textbook this week to help study for the exam, which is this Friday at 1:30, you need to be signed in. It starts at 2. If you want to keep your textbooks, you can and return them at a later date for us. But again, your exam for everybody is 2 p.m. this coming Friday. Make sure you sign in at 1:30, have your materials, your papers, your calculators, your formula sheet, etc. all set for you. Now let's begin with Chapter 7, Sampling Distributions. We learned a lot in this chapter. We looked at parameters versus statistics, and we looked at sampling variability. We looked at the sampling distribution of p hats, of x bars, and this is where we introduced the central limit theorem. This chapter was a very big foundation for inference for us. So there's a lot of important concepts that you see repeated throughout chapters 8, 9, and 10. So let's begin with the sampling distribution of p hats. Now, this slide, we're looking at the idea of at least 10 successes and 10 failures. Now, there is a URL to a simulation website which deals with this, where we look at the simulation of a sample distribution of p hats. So let's take a look at that website for a minute. So right now I have a population proportion p equal to 0.3, and I have a sample of 100 for this. Now if I take a look at it and I generate one sample, so I grab 100 and I take the sample proportion of that, boom, I plot it, there we go. And I'm going to do that again and again and again. So I keep on taking samples of 100 and finding the sample proportion of it and then plotting it on the number line. I do that repeatedly and repeatedly and repeatedly. That's what creates a sampling distribution of p hats. Now I'm going to do this many times. And as we do this many times, we start to see the shape becomes approximately normal on it when we have at least 10 successes and 10 failures. And in this case, I do, because 0.3 times 100 is 30. 0.7 times 100 is 70. I have at least 10 successes and 10 failures. And so therefore, the shape of the sampling distribution of p hats is approximately normal. Now, if I were to take my sample size, let's reset this, and I take the sample size and I go down to 20. Now, in this case, if I take 0.3 times 20, I'm going to get 0.6. I do not have 10 successes and 10 failures. So again, I'm taking a sample of 20, calculating the sample proportion, plotting it on the number line, and repeating that over and over and over and over again. And I'm going to generate many samples of it. And you can see the shape is not approximately normal. And I don't have enough successes and enough failures to get the shape to be approximately normal. And so this applet goes through that. So let's go back to our slides. Now we do this, the shape of a sample distribution of p hats, it doesn't matter what the population distribution of it is, what the shape of that is. The shape of the sampling distribution of sample proportions p hat will be approximately normal if you have at least 10 successes and at least 10 failures on it. The center, your population proportion p, is going to be equal to the mean of all those sample proportions. So the mean of p hat, mu of p hat. The spread of it is going to be the square root of your successes times failures divided by your sample size. If your 10% condition works, 10 times the sample size on your population, it has to be bigger than that. That is the idea behind the sampling distribution of p hats. Now, when it comes to an AP free response problem, let's look at that. Oh, look, there is from our database, from our spreadsheet of index with our free response questions, this is all of the free response questions from up to 2018 dealing with sampling distributions from Chapter 7. None of those deals with a sampling distribution of p hats. Interesting. So let's look at speculating. I'm going to speculate that there has not been a single question when you have looked at it that deals specifically with sampling distributions of p hat following Chapter 7 concepts on it. However, confidence intervals, significance tests, they all heavily rely on the material learned in this with shape, center, and spread of the sampling distribution of sample proportions. So though there has not been a Chapter 7 question with p hats in the sampling distribution, the material from it is still on the exam in the free response of confidence intervals of significance tests dealing with shape, center, and spread. So the formulas may change, but the concepts are there. So there was no free response question dealing specifically with the sampling division of p hats. It was in questions that deal with chapter 8, chapter 9, chapter 10 with confidence intervals and significance tests with p hats on it. So it's still there, but not specifically with chapter 7. So let's go to X bars. Now this was the fun one. This is one we really enjoy using a lot, and that's the central limit theorem on it. Again, another simulation website. So let's take a look at that. Website works about the same way as the other one did, as I have in this case though a population distribution shown. So I can see it's right skewed, and I can change a little bit by clicking and dragging down, so I can make it right skewed. I can even make it a little more right skewed if I want. And what I'm going to do, and I'll do it a little bit, is I'm going to increase my sample size to 25, not quite 30, but we'll manage. And what happens is I will collect 25 dots. And I'm going to take all those, I'm going to take that sample of 25, and it's going to calculate the mean of that sample, and then it's going to plot it right below it in blue. Boom, it went. And it does it again. And so as I collect 25 and I find the sample mean of that size and plot it, I will put it down there. Boom, I'm starting to generate a sampling distribution of X bars. And I'm going to do it repeatedly, and you can start to see the shape is approximately normal. And not just that, look at the information on it. The mean is 9.87 for the parent population. The mean when it comes to your sampling distribution of X bars is 9.87. They are really close. Now you have the standard deviation of the original 7.01 because it was skewed, but now standard deviation is smaller. So somehow our formula has to make the standard deviation smaller on it. And so that's how the central limit theorem works. And it doesn't matter what the shape of the distribution was on it. I can just keep doing it and see, boom, I can make it like this and it's going to work. It doesn't matter what the shape of the population distribution is. Here you see I have it hidden, and I'm going to do the same thing. I will change this to 25. I'm going to animate. I'm going to collect from a population, an unknown population, and I'm going to collect 25, and I'm going to find the mean of that sample size of 25. I'm going to plot it down below, and boom, it gets plotted. And I'm going to repeat that over and over and over again. And so even though I don't know the shape of the population, the shape of the sampling distribution of X bars is approximately normal. And what's nice is I see here the mean is 13.69 for this sampling distribution of X bars. So if I take a look at that. The mean for the parent is 13.7. They are so close to each other. And so there is that applet that deals with the central limit theorem. Overall, it doesn't matter the shape of the population distribution. The shape of the sampling distribution of sample means, X bar, will be approximately normal if the central limit theorem is met, which means the sample size has to be greater than or equal to 30. The center, the population mean, is equal to the mean of the sampling distribution of it, and your sampling distribution spread is equal to your population standard deviation divided by the square root of n, and that's what's going to make it smaller. Formulas are on your formula sheet for it. And so if we take a look at that, here is a question from the 2007 test. I'm not going to read the question, but I can see you have here the number of dogs and cats on the x-axis, the relative frequency of it. There's a part A, part B, part C. You can read it and take a look at it. Part A does not deal with chapter 7. It's just calculating probability from a display of population frequencies. Notice it does say show your work on it. And so here you're just looking at trying to figure out which of the bars you're going to add up to get your answer on it. Part B, not from chapter 7. It deals with binomial. And so one thing we're thinking for speculation is you can't do really hardcore binomial calculations without using a graphic calculator. And they said no graphic calculator. So maybe they're going to ask you to check the conditions, which was in the previous video with bins on it. Maybe it might ask you to set up the calculation for binomial probability, but not actually do it. Those are some speculations, but part B is from binomial, the previous chapter. Part C is chapter 7 content. It's asking you to describe the sampling distribution of a mean from a large sample. So it tells you the mean and standard deviation of the population is 1.65, 1.851 respectively. It creates a sampling distribution of X bars, and it's asking you to describe the shape, center, and spread of this on it. So you can pause this, you can take a look at it, and figure out what the answers are going to be for it. What's the shape, what's the center, what's the spread, which goes back to the central limit theorem and the stuff on this slide. The population mean is going to equal to the mean of the sampling distribution of it. The spread is equal to the standard deviation divided by the square root of n on it. The shape will be approximately normal if your sample size is greater than or equal to 30. And now here's another one. This is from 1998. You can pause it and take a look. Your turn. You can try it and read through for it. Overall, here are the conditions that deal with it. You have the sample distributions of p hat, shape, center, spread, sampling distributions of x bar, shape, center, spread. I apologize. Some of the characters did not show up. So let's put them in right now. All right, that's better. So now you have them on there. You can see it for there. And one thing that's really nice as well is we put in a lot of resources for this. You have 3 videos linked on here. You have the 2 links to the simulators, and you have the free response index that we've been looking at for the Google spreadsheet. Also, we have updated tons of resources on our Schoology courses. Right, we put a folder with the posters. So we have all the posters from Mr. Manickel's room. We have them as pictures inside a folder. You can take a look at it. We also have, if you want to practice naming that inference, we created 5 choose the inference procedure tests on Schoology. And you can look at those. There are 26 previous AP prompts you can take a look at for it. Also, there's the step 1. These are all the previous videos are on Schoology. Step 2 has the amazing exam resources. You can see right there, pictures of classroom posters is now in that one. Step 3, practice naming that inference. There's those 5 tests you can take. And step 4, more mock exams. We have found some more mock exams if you want to do some more practice. And we even posted the scoring guidelines to each one of those for you. So that is what we have for this week. We hope you're all doing well. Please stop in office hours, ask any questions that you have.